Don't know much about algebra. Don't know what a sliding rule is for. But I do know what and what is two. This one could be with you. What a wonderful world this would be.
Welcome back, everybody, and welcome to Mr. K's 30 Minutes of Math. I hope you're all doing great and enjoying the beautiful day out there. We have lots to discuss, so let us get started with our riddle from yesterday. So hold on one second, I'll get that up. As you may recall, we had this interesting time puzzle, which involved Sophie and Caroline. And I'm going to read it just to bring us back to where we were. All right. Sophie and Caroline made arrangements to meet at a cafe at 2 p.m. Sophie thinks her watch is 25 minutes fast, although it is 10 minutes delayed. So when it is 2 o'clock on her watch, she thinks it's actually 1:35. She thinks it's 25 minutes fast, but really it's delayed by 10 minutes. And then Caroline thinks her watch is 10 minutes slow, but it's actually 5 minutes too soon. So what happens if they both aim to arrive precisely on time? This was a tricky one. Anybody able to figure this one out yesterday? You can go ahead and type in. I see Delilah writes in, I think Sophie got there at 2:15 and Caroline got there at 1:55. Donna did not have a chance to figure it out. Let me see if anybody else. Delilah says, it hurt my brain. Yes, this was a tricky one. Well, let's try to figure it out together. So here, let's start with Sophie. Whoops. And okay, here's a little number line, a little timeline, and let's call this 2 p.m. So she thinks her watch is 25 minutes fast. So for example, at 2 p.m., it's really 1:35 p.m. That's what she thinks. So if she wanted to be somewhere at 2, she would go there at 1:35 because she thinks it's really 1:35 plus 25 minutes, which would be 2 p.m. But really, it's 10 minutes delayed. So it's not actually 1:35, it's 10 minutes behind that, which would be 1:45. So Sophie's going to get there at 1:45. And over here we have Caroline, and I'll do the same kind of thing. Here's 2 o'clock. She thinks her watch is 10 minutes slow. So when it's 1:50 on her watch, she thinks it's 2 o'clock because she thinks her watch is 10 minutes slow. But it's actually 5 minutes too soon. So if she goes at 2, then, if she wants to be there at 2, she's going to go at 1:50 because she thinks it's 10 minutes too slow, but she's actually 5 minutes too soon, which would put her at 1:45. So there you have it, folks. Kind of a crazy riddle, but yes, it was hard, very much so, confusing. I apologize. Maybe we'll get one a little bit clearer next time. All right, let me just fix one thing on here. Whoops, sorry about that. All right, let's get to last night's homework. Let me bring the screen back. Sorry for the slight technical difficulties, but we will get that resolved in just one second. And I think I've got it almost set up. Here we go. And 3, 2, 1, 0. All right, there it is. I got it back. Fantastic. All right, so last night's homework, we were doing our decimal and fraction comparison. And we were writing each of these in decimal form. So I believe we started off 2 ones and 2 hundredths, and that would also be 2 and 2 hundredths. Here, 2 ones and 16 hundredths, which would be the same as that. 3 ones and 7 hundredths, which would look like that. 1 and 18 hundredths, which would look like that. 9 ones and 62 hundredths. I see folks writing in, fantastic, which would look like that. And F, 6 ones and 20 hundredths, which would look like that. All right, well done, guys, well done. All right, let's move on to our next one. Here we are going to do some connecting of the dots. So here's my question. If I start with 7 ones and 13 hundredths, where should I connect the dot to? Go ahead and type it in. What should that be connected to? Go ahead and take a second. What would 7 ones and 13 hundredths be connected to? Would it be 7.30, 7.3, 7.03, 7.13, 73? Which one would it be? Well done. I see a few folks writing in 7.13. That's right, because that is 7 and 13 hundredths, which is the same as 7 and 13 hundredths. So that all connects. Great. 7 ones and 3 hundredths. Which one would that be? 7 ones and 3 hundredths. Which one would that be? Go ahead and type that in. I see Delilah writes in, and well done, Delilah. Anybody else think you've got it figured out? Donna, very good. Excellent job. Ezra, excellent job. 7 ones and 3 hundredths. Here it is. And that's going to connect to that one over there. Okay, 7 ones and 3 tenths. 7 ones and 3 tenths. Which one would that be? 7 ones and 3 tenths. Go ahead, take a second and type it in. Excellent job, Ezra and Donna. Very good. 7 ones and 3 tenths right there, which would be the same as, oh, interesting question. Whoops. Let me move this out of the way. 7 ones and 3 tenths. Which one should I connect it to on the fraction side? Ooh, Delilah writes in, it could also be this one. That is correct, because 7 ones and 3 tenths is the same as 7 ones and 30 hundredths. And so which fraction should it go to? We don't actually have this listed. So what should I go to? Well done, folks. I see Ezra writes in, Delilah writes in. We're going to go to 7 and 30 hundredths. So both of those could go there. Excellent job, guys. And then last, let's do this one in yellow. 7 tens, 3 ones. 7 tens and 3 ones. What is that? 7 tens and 3 ones. They threw this one in just to be a little bit tricky. That is right. 7 tens is 70 and 3 ones would be 73. Excellent job. You guys rock that. All right, let us try this one. We're going to use this place value chart, which should look familiar. All right, which digit is in the hundreds place? Well, that should be clear. That's the 4. And so what is the value of that 4? It's 400. All right, which digit is in the tens place? Go ahead and write it in real quick. This should be easy peasy lemon squeezy. Which digit is in the tens place? That's right, the 1, and that has a value of 110 or 10. In the tenths place, which digit is in the tenths place? The tenths place. Go ahead and type that one in. Let's see what we've got. Very good, Donna. She writes in 8, and that has a value of 8 tenths, which is also 0.8. And in the hundredths place, very good, you guys are already ahead, 3, and that has a value of 0.03. Very good, very good. You guys are rocking it. All right, let's try this one. It says, write a decimal number sentence to identify the total value of the place value discs. Okay, so let's take a look at this. We have 3 tens. 1, 2, 3. How much is 3 tens? 30. And then we have 4 tenths. Here's 1, 2, 3, 4. How much is 4 tenths? How much is 4 tenths? Very good. 0.4. And then we have 2 hundredths. 1, 2, 0.02. And if we bring that all together, what would I have? Well, I'd have 30 and 4 tenths, 2 hundredths, 30.42, which is the same as 30 and 42 hundredths, which shouldn't make sense because 40 hundredths is the same as 4 tenths, and then we'd have 2 hundredths left over. Okay, and the bottom one, how would the bottom one go? 5 hundredths, that's right. 3 hundredths, each of them is 0.01, so 3 of them. And so what would our number be? 503 hundredths. Well done, guys. You guys are doing a fantastic job. Okay, let's get to our joke of the day. What do you get when an elephant sits on an angle? Go ahead. Okay, I have Delilah writes in a squished angle. Donna writes in a sloped angle, and Ezra writes in a straight line. Those are all really, really good answers. I should start adding these to my repertoire. Well, here is the answer, though, that I had. A rectangle. Yeah, that's a bit of a grunter, but I like that one, a rectangle. Really, if you had an elephant sitting on an angle, you would not get a rectangle. It would be a complete mess, but it sounds funny nonetheless. All right, speaking of rectangles and squished angles and sloped lines and such, let's go ahead and take a look at this interesting shape. Let's go ahead and first, let's do this. I'm curious if you guys can just figure out for me, if that's A and that's B, what would the coordinates for A and B be? And I know it's a little bit tricky because it's not right on an intersection, but I'm curious if you guys can figure it out. What would the coordinates for A and B be? Go ahead and take a second to try to figure that one out, and I'll give you some music. You guys are amazing. I'm so proud of you. It looks like everybody got this. So A would be, remember, always start at the origin. 1, 2, 3, 4, 5, 6 to the left, so -6. And then we're going up halfway to 1, so well done. -6 and a half. And then B would be 1, 2, 3 to the right, so +3. And then we're going up, and again, we're only going up half a unit. So there you go. Fantastic. Well done, guys. Really impressed. All right, now what I'd love for you to do, let's bring back our friend, the ruler, and let's go ahead and put a line in. And I would like you guys to go ahead and determine the slope of that line. Go ahead. Okay, let's take a look if we are doing the slope. And I'm going to use, let's see, I'm going to use this point here. Let's call that C. And I'm going to use this one right here. Let's call that D. But we could also use this one, E. And actually, you know what? On second thought, I think this one, whoop, sorry about that. I think that one right there might not be exactly where we want it to be. So let's use this. We'll just use this and make it a little bit simpler. Okay, C to D. Let's count our rise, 1, 2, and then our run, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we went to the right, so it is +2/9. Very good. Now remember, we could go the other way. I could do D to C, and I would go 1, 2 down, so that'd be -2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be to the left, so -9. Remember, as I shared with you yesterday, -2/9, and I'm sorry, -2 over -9 is the same as +2 over +9, but that gets into some other stuff, which we will do later. All right, fantastic work indeed. Let's try one more. Go ahead and let's figure out the slope of this line, and I'm going to do green for this one. And take a couple of seconds to go ahead. Whoops. How do I get rid of that guy? Let's do that. Okay, go ahead and work on that one. Okay, let's take a look. I am going to, let's call that a point and that a point, A and B. All right, let's do our rise first. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's up, so it's positive. And then 1, 2, left, so it's negative. Negative 9 halves. Now, you could have also done, starting at B, 1, 2, 3, 4, 5, 6, 7, 8, 9 down, so negative 9. And then 2 to the right, 1, 2. And these are the same thing. You can write them both by just putting the negative sign there and calling it negative 9/2. Now, what's interesting is you'll notice that this one was 2/9, and this one was negative 9/2 because all that we did was rotate the shape. So I wasn't sure if you guys saw that, but wanted to make sure that to point it out. Okay, let's get back to our fractions and decimals. Here, what we are doing is converting from one side of our equation to the other. So 2 1s equals how many tenths? And what they want us to do is show place value disc. So let me do the first one for you. 2 1s equals how many tenths? So if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and each of those was 0.1, that would turn into 1 whole. And then I'd have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those would turn into 1 whole. So 2 1s is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 10 more, 20 tenths. 20 tenths. All right, go ahead and do these other 3. 2 tenths equals how many hundredths? 1 3/10 equals how many tenths? 2 tenths and 3 hundredths equals how many hundredths? Go ahead and take a minute to work on those. Okay, welcome back. And I see some great answers coming in. 2 tenths equals how many hundredths? Well, let's see if I had, whoops, let me get my 1/10 here and 1/10 here. That would give us 2. And how many hundredths? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each of those would be 0.01. That would make 1. And then I would have to do another 10 to make another whole. So 20 hundredths, well done. I saw a lot of those coming in. Here we have 1, 1, and 3 tenths. And how would I turn that into all tenths? Well, we have 3 tenths, and then I want to get 1 whole. So I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there to make our whole. And I have 3 more, so 13 tenths. And then here, 2 tenths, 3 hundredths. 2 tenths, 3 hundredths. So I have 2 tenths and 3 hundredths, and I want to turn it all into hundredths. Okay, well, these 2 tenths would each be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths. Those become our 2 tenths. So I have 10, 20, and 3, 23 hundredths. Well done, everybody. All right, one more before our homework and our riddle for the night. It says, use the area model to represent 250 100ths, 250 100ths, and complete the number sentence. So why don't you go ahead and work on the number sentence, and I will be back in a second to do the drawing. 250 hundredths. All right, welcome back. I see a lot of great answers coming in. Let us take a look. 250 100ths. Well, right now you'll see in our area models, we have tenths. These are tenths because they're split up into 10 pieces, but I want hundredths, okay? So I'm gonna decompose these into hundredths. 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, they're not perfect, but you get the idea. All right, 250 hundredths, 250 hundredths. Well, each of these is now 100, so here's 100 hundredths. Here's 200 hundredths. And then 50 more, 10, 20, 30, 40, 50. So that's 250 hundredths. All right, how many tenths is that? Well, if we go back and remember, how many tenths did we have to start with? If we had one, gosh, I keep using the wrong tool, my apologies. Whoops, 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 let's get that back. All right, how many tenths did we start with? Well, this had 10. Remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, it was these bars that we had at the beginning. And this had 10. And actually, I did these horizontally, so I apologize. But that's 1 10, and that's another 10, and that's another 10th. That's another 10th, and that's another 10th. So we had 5 more here. So altogether, we had 25 tenths. And now we know that we have 2 ones, and then we have 5 tenths, which is the same as 2 and 5/10, which by the way is the same as 2 and 50 hundredths, which by the way is the same as 2 and 500 thousandths, and so on and so on and so on. Well done, guys. Well done. All right, here is your homework for tonight. Go ahead and take a screenshot or take a picture or jot it down. We have a decimal number, and then you have to put it into a mixed number, then put it into tenths, hundredths, and thousandths, which takes us one more place value to the right. So go ahead and take your picture or your screenshot. All right, finally, whoops. Let's get to our riddle of the day. Here is the riddle. How many moves are required to transport the balls from tube 1 to tube 3 if all the balls must remain in the same order? So you have ball 1, 2, 3, and you want to get them lined up in the same order. So 1, 2, 3, but you can't take them all out and move them around. You can only move one ball at a time. So how many moves would it take, and what would those moves be to get them from tube 1 all the way over to tube 3 in the right order? And that's the important question. All right, I hope everybody has a great day. Thanks for joining me again, and I will see you tomorrow. Have a wonderful afternoon. Bye, everybody.